Hello everyone. Today I want to try something new, maybe a multi-part series. I'm not quite sure. The idea was I'd like to learn some stuff about networks, network programming, and I thought it would be fun to implement an HTTP server. So we want to create a web server which can handle requests and form a response to the client. I would like later on to implement Go routines to take multiple requests, handle them separately. I would like to be able to pass my disk for requested HTML files, other resources, and also form a response and reply to the client. I have no idea how to counter this, so this is probably a slow-paced video. For today, my goal would be to have like a ground base. I want to have a listener, TCP listener, which listens to a port, and just have a simple while loop that takes requests, accepts connections first, and yes, just print out the request. So at the end we want to type in our browser localhost, let's say 8080 as a port, and then just print those bytes that were sent to the terminal. Should be straightforward, right? I know there's a net/HTTP package in Go standard library, but obviously we will not use this. I want to implement everything that I can and want to implement that from scratch, because that's the way I learn the most about it, and I'm sitting here in my free time. I want to have some fun programming. So there's not the expectation from my side to have a good functional server at the end. It's just a fun little thing. And yes, so let's start. We want to have a look at the net package, because that implements a portable interface for network I/O, including TCP, IP, UDP, domain name resolution, and Unix domain name sockets. I already worked with that package once, and it's quite straightforward, because that's very, very low level stuff I don't want to handle. Exactly. If you are a client and want to form a request to a server, you would use this code where you use the dial function and specify the protocol you want to use, for example TCP, and the address of the server. And then you can have an error. You get a connection, and I'm not that sure what this bit does, but we want to create a listen function for a server. The listen function creates servers. So there's a listen function which just accepts an incoming connection request via for example, a dial function. We also specify the protocol we want to use, TCP in our case, and the port we listen to. And then we have a loop where we wait. This function will probably have a switch statement or some kind of loop that just waits for clients requesting stuff. Then it accepts this connection, handles error stuff, And here we already have like a Go routine for handle connection, because that would be obviously best practice, because during the time we handle the request, we want to be able to take another connection, another request from another client, because we are a web server. But in this first part, we will just handle the connection here, and then the next client would have to wait for us to be ready to be able to request something. All right, looks straightforward to me. Let's start. I did not explain yet how any of this works in networking stuff. Maybe let's have a look at it. TCP IP model. No, that does not look helpful at all, actually. But TCP is a protocol in the OSI layer model. Any one of you who visited school for computer science or university will have seen this a lot of times. Usually there are 7 layers actually, but it's okay to just compress them to 4 layers. At the top level, it's an application layer. So there live protocols like HTTP. That's a protocol we want to implement, basically. And other stuff. Then there's transport layer, like TCP, UDP. Then they call it an internet layer, IP protocol, for example, and a network layer, Ethernet, Wi-Fi, physical stuff. Every request, like when you call google.com, your browser requests the site from the Google server. So we start at the application layer. Then we get to the TCP protocol, which puts everything into packages, if I'm correctly informed. Like our whole request cannot be sent as one, but as many little packages of a predefined size. And TCP protocol, I think, handles this stuff, like puts everything in packages and so on. And then we have the internet layer, they call it here the IP protocol, which performs the routing. So it knows where the next PC is, like where the Google server is. It obviously hops many other computers and servers on its way, but for simplicity, it would know, hey, there's my destination server, and I know how to get there. And the physical layer, first layer, Ethernet, is like handling the physical stuff, actually sending bits via copper cable or fiberglass or over Wi-Fi or mobile. Yes. All right. So we kind of know where we are. We are here, and we want to implement layer 4, like the HTTP protocol. All right. Let's copy that. And we don't need this anymore. My hello world works. Oopsie. And I just copied the hello world. Let's copy this. All right. Let's format the stuff. We obviously did not import net yet, so let's do this. We want to listen. TCP port 8080 is fine, I think. We will not handle errors for now. Maybe we just say error. Error listening, or something like this, listening. So we know where it comes from. Then we go into our loop. Maybe we should like log something here. Anyone interested in how the print functions are working under the hood? I made a video about it. You can watch. What do we print here? Let's say server ready to serve on port. Let's have a variable for that, right? Const port equals 8080. And then we no, okay. It's a string. Perfect. Because then we can right here we could say log print line starting server. We don't need the scope thingy. Why can we not? We did not declare that not used. Yes, exactly. Yeah, what do we want to do actually with our connection? Maybe we should have a look at what this connection thingy is. Right? So that's type, func, okay. We need the listen function. Okay, it's an hyperlink here. Perfect. Listen announces on the local network address. The network must be TCP. Okay. For TCP networks, if the host and the address parameter is empty or literally unspecified IP address, listens on all available unicast and anycast IP addresses of the local system. All right. Okay. To only use IPv4, use network TCP4. Okay. But this is not, the address can use a host name, but this is not required. If the port and address parameter is empty. Okay. Yes. But what does it return to us? Because it's returning a listener. Okay. Type listener interface accepts, waits for and returns the next connection to the listener. Yes, exactly. And connection interface reads data from the connection. Read can be made to time out and return an error after a fixed time limit. Yes, that's quite okay. I understand. Read, write. Okay, so after we accepted the connection, we probably want to read the data. We can write to this connection, which probably holds like, does this hold? No. Okay, that's an interface which implements some functions, yes, but how does it know where to write to, right? Someone or something has to know where the request was from. It's not the type listener. Listen. network, is an error. Is anything useful here? Doesn't look this way for me. Okay. Type listener. Listener is the generic network listener for stream-oriented protocols. There's an example. Examples are very useful. So, wait for connection, listener.accept. Handle the connection in a new Go routine loop, then returns to accepting so that multiple connections may be served concurrently. That's exactly what I was talking about earlier. Go funcnet.connection. So this Go routine takes the connection, echo all incoming data, copies it to itself. Okay. I have no idea what this io.copy does except from copying, but it obviously somehow triggers a response because it says echo. Okay, but that's actually not too important how we know where to write to, because it seems to know it. Write can be made to time out and return after an error. Return error after a fixed time limit. Yes, okay. So this takes byte slice as an input. This also takes byte slice as an input. So we need to create a buffer, a byte slice, where our data is read to. So we have a fixed length because we have no idea how big the request is gonna be. Let's try 4096. That's a very usual common buffer size, because I think that this is the size of a memory page or something like that. Memory page size. Yes, 4 kilobyte is the most common default, and so the buffer can be transferred between physical RAM and virtual memory in one go, because that's the biggest, smallest fixed size block of data actually. Okay, not even the biggest. We just see if our buffer will be big enough with 4096 bytes. Maybe I like Google search later on what the most common size for a web server, so we can ask the AI. Okay, we can close the connection. Okay, and we can like get the address that would be the source address, the origin where our request comes from. But we will not need that yet. So we create a buffer, then we read to the buffer, or probably would be useful to clear it first, in case there's something in it. We get a return value n, which is probably the amount of bytes that were read. Would be logic to me. Would be nice if it is actually documented somewhere. Maybe this is too simple to document it. I don't know. The right part we will not need yet actually. We just read the byte slice and then we just print it to the console, right? Should be done quite quickly. So where do we create the buffer? I would say here, buffer. Yes, I did not program in Go a while. How do we create a byte slice? Well, not this way. Byte? No, we need to. Yes. Cool. And we can say it's a fixed length of 4096 bytes. Do we need a fixed length? I have no idea. handle connection. To do outsource to go routine. All right, so we have this. We have n and error, I think. Right? Yes, exactly. And then we say buffer. What? Why can't we just put our buffer? Can it use buffer of type as byte? Because it has a fixed length. And we will not. We don't need. All right. Do we pass it as a reference? Because no, it's a slice. We do not. All right. Yeah, that's basically it, right? We say, obviously, we say if error not equals null, we want to like some. We want to log this somehow. Do we just format println or log? Let's use log. I like log. Fatals equivalent to print followed by a call. Now yes, we want to use fatal. Error reading connection. Then we say error.error. No, why? Why don't we say error.error? But it returns a string, doesn't it? Well, then we format it and say this, and then error.error. Okay, perfect. Is there a new line? Yes, probably there's a new line included anyway. Then, if there's no error, I would say we log to console successfully. I want to have like a log print. Established new connection from and then like the con remote address. Can this be read as a string? Because there is no string. String. Yes, perfect. Successfully read bytes. N. And then we log printf. Request. Just print it as a okay, we can use this n to just do this, right? We read from the start up to the point where the request ends. Should work. And then we would like to close, because we don't answer yet. Close the connection. Buffer dot. Is there like clear? I probably would have like clear. How do I like put everything back to 0 or something like that, you know. So because the problem is like, let's imagine we write 100 bytes and the next request only takes like 50 bytes. Then there are still 50 bytes from trash bytes from the old request. Sure, we have the parameter n to know that we only read 50 bytes this time, but I think it would be more clean to clear the buffer anyways. So I would like to do this. Go slice clear. In Go, you can clear slice by using the built-in clear function to zero out its elements. What clear function? Ah, I see. Clear. Ah, check. And this probably strings become null, pointers become null. Okay, a byte slice would probably be 0 as well, right? Setting to null. I don't want to do this. Best practice and memory leaks. When reslicing and reusing slice, any pointers objects previously held on the. Okay. Right, we have our buffer. We read in our buffer. We close the connections. We need to log that. Log printf connection closed. Actually, we don't need to. I hope that every printf puts a new line character at the end. I'm not too sure, but we will see. It would be quite chaotic in the terminal if there's no new line character. We should probably put something up here like ready to accept connections, because that would be helpful. And how do I switch tabs here? I think that's it, right? Let's start this, see if it compiles. So we go run it. Server ready to serve on port 8080, ready to accept connections. Looks good so far. Localhost 8080. Well, what is this nonsense? Ready to accept connections. Established new connection from our port our server obviously used. Our browser, sorry. Successfully read 0 bytes. Request connection closed. Ready to accept connection. Is it like an empty request? But why are there so many? No. Let's start server again. And let's put this in. Just side by side. And let's have a look at the network tab and refresh. No. Transferred 0 bytes. Request pressure. What is our blocked? Why is it blocked? Because like we have 466 bytes request headers, so we would probably expect them to be to be printed to the console, right? But the status is blocked. Like the port is not correctly opened or something. Do I ask AI? Do I not? Let's have another look at the reads data from the connection. Read can be made time. Yeah, but that's not too helpful actually. Read from the buffer. Read implements our buffers for buffers. Yes. Okay, that's not interesting, I think. Where's our example? It was at the top right. Handle connection, it just says here. Okay, that's not too helpful, actually. Okay. I'm kind of out of ideas. Let's try again. All right, so something missing between like the accept and the read. Accept waits for and returns the next connection to the listener. So we would think establish new connection. That's good. Those are different ports. Interesting. Do web browsers use a different port like for every request they make? Would be kind of logic, right? Wouldn't it? Because the browser needs to wait for the response from the server, and that can take like seconds or stuff. But the port is like blocked for this time because imagine we would always use this port and we make a request to Google and our internet connection is bad or whatever. It takes 3 seconds for the response. And in this meantime, we perform another request and get a response. Then we have like problems separating the data and stuff. So probably for every request, a web browser uses different port. We have a lot of ports, so that's no problem. Very interesting. Already learned new stuff. Perfect. But that obviously does not get us to our goal of the episode. How long am I even recording? 33 minutes. Okay. Reads data from the connection. Read can be made timeout and return error. Yes, but that is not the best like documentation, right? How can it actually be made timeout and return error after a fixed time limit? Because the only parameter it takes is a byte slice. Just say. Interesting. Okay, before I give up and you say we will use the good old Google method. Go net read 0 bytes. Sounds like an issue we have. 0 byte read from TCP connection always return NF file. My understanding is that the recommended way to test whether TCP connection has been closed by the remote peers to do a 0-byte read from the socket, which would return NF5 to remote peers send a fin package. Unfortunately, that doesn't work in Go, as always returns NF5 when 0 bytes are read, regardless of the requested read size. Is that on purpose? Okay, tries to read from a connection and checks if the error is end of file. So I can tell all versions of Go have a variation of the following. So when Cisco read returns a n equals 0 bytes read, as it always will when 0 bytes are requested, is will always result in TCP conpunct returning end of file. Am I missing something? Added interesting. Okay, there's one more I can check for, because I have written a peer-to-peer chat at university some time ago, 7 months ago actually, and it used UDP as a protocol, but I know that I used the net package somewhere, probably at peer.go. Exactly, here it is. And listen UDP, yes. We have the connection. No, send message. Broadcast internal, get alias. Where was it? Messages.go. Handle incoming package. Yes. What did I do here? Sending a message, go routine for receiving a message. Perfect. Chat log timestamp, new log. Chat, that's not interesting. We have a buffer. We did it with make buffer, max buffer size. That's better, I think, than the way we did it actually. Let's do that as well. We don't need this. So our buffer will be done with help make buff 4096 does not work because that is not correct. But maybe this changed something. Maybe there was something wrong with like the initiation of our buffer. Let's. Yes, is it actually was a very simple mistake, I think. But what I still don't understand is why we get so many requests, but one step after another. So we have, because we only see in our network tab in the browser, we only see this one get request. Let's see. What do we get here? We actually get the request, right? I have some basic knowledge of the HTTP protocol, and I know that it starts with like the method, then the version, then there's the headers, host, user agent, some other headers I don't know what they are. For connection, keep alive. Okay. Upgrade and secure. Never seen that before. And that's it. It's like that's probably the path we're requesting, right? Because we did not specify any route or something. But if we would say localhost / users, would there be users here? Maybe. I mean, let's try it, right? But first, is there anything different in the other requests? Yes, there is something different, right? No, there's not. Then I have no idea why. Let's say users. It spams our terminal actually. And it always says connection closed, ready to accept connections. And so there is definitely more than one connection established, and this means more than one request made, right? The core stuff I did not see the last time, did I? But request head / users. Head? What is the head method? I thought there would be get, but I was wrong, obviously. Okay, but I was right about the route. That's good, that's good. Okay. I think for now this is enough, right? It's very basic, obviously, but in the next episode, our goal would be to have a little request parser, which means that's all just plain text, right? And we would like to extract the method, the route. That's not too interesting for us, but there are some things we want to have. So we would need to tokenize the string to extract every important stuff for us, and that would be the goal for the next episode, I think. All right. If you made it so far, thank you for watching. I hope you learned something new as well, or had some fun, or it was relaxing to watch. I don't know. If you know stuff about this topic, put it in the comments. Why do we have that much requests? And hopefully you tune in next time. And until then, have a good time.